In this video, we're going to export GDSII data for tape out. But before we do that, what we need to do is use Hyperlink's DRC to run a final degassing pass on the RDL layers. This ensures that the copper density is balanced evenly across the entire substrate on all layers. Hyperlink's DRC is now scanning each layer and calculating the copper density as it goes, and identifies locations where extra degassing holes can be placed. It starts with a 30 by 30 micron hole, then 20 by 20, then 10 by 10. The counter indicates the progress on each pass. Once it reaches 0, that pass is then complete, and it moves on to the next stage. So once that completes, the end result is a series of files that for each RDL layer that you can now import into Xpedition. And using a simple tool, which is going to select the input files and the layers, and then that actually adds all the extra degassing holes into the design. I'll just zoom in here and we can see some of those additional degassing holes. So now we're ready to start the GDS process. First thing we're going to do is set up our GDS export scheme. This we do with a simple wizard, which will look at all the layers in the design and automatically create a set of output layers and mappings that we can then use in the GDS export process. And now from the Packaging Utilities Toolkit menu, we'll select the GDS final output. And this is where we start the whole GDS export process. What we see here is the pre-processing stage, where an advanced geometry engine renders complex shapes containing true arcs and circles into extremely clean vectorized polygons that is then exported into the GDS2 format. Take a look at the GDS2 data and take a look at the extremely clean results that have come through from the preprocessor. We'll use a basic GDS viewer to look at the results here. Just double click on the GDS2 file and then open up the viewer. Let's turn some layers off, and then we can take a look at one of the RDL layers. And when we zoom in, we'll see extremely clean GDS polygons. Key points here being anywhere where there are traces merging into pads with teardrops. These are typical areas where many other CAD systems have severe problems with quality, where jagged edges, acute angles are found, and these lead to thousands upon thousands of false violations.